Dude.
Are you?
So I wanted to, so I take the test next Wednesday.
Uh-huh.
But I think what's best now is we start trying to pick up the speed,
Uh-huh.
and I'll try to solve the problem until I run into an issue, and then I guess you step in and help me out and clarify it.
Okay. Sounds
That way
good.
we get maybe more problems, and that way I guess I'm doing more. So
Okay.
where do you want to start?
Well, let's talk about this problem 149 first of all. I think an important concept for you to know is that, hold on a second, let me pop open my, if you go someplace at an average speed of 40 and return at 60, you do not average 50 miles an hour. If you go from Colorado Springs to Denver at 30 miles an hour,
Yeah.
it takes 2 hours. If you return at 60 miles per hour, it takes 1 hour. What's your average speed?
So it's 30 plus 60 over 3, so that's 90 over 3. I'd say it's 30 miles an hour.
No, can't be 30 because you went 30 for the first. You drove 30 miles per hour coming up to Denver, but you went back at 60 miles an hour. So to get the average speed, we have to figure, well, what was our total distance traveled? If you assume it's 60 miles between Colorado Springs and Denver, we traveled 120 miles. We took 3 hours, so our average speed was 40 miles per hour. In other words, what I'm trying to say is you never want to really compare this to this. You're going to have a hard time coming up with the correct answer. And the reason it's not 45 is because we spent 2/3 of the trip traveling at 30 miles an hour. We only spent 1/3 of the trip traveling at 60 miles an hour.
Yeah. So
On distance rate time problems, this is a frequent type question where the instinctive answer would be to say 45 miles per hour would be the average speed. And it's not the case.
Okay.
Okay? In other words, you always have to figure out the total distance traveled divided by the total time is going to give you your average.
Okay.
All right, let me shrink this a little bit. And did we do 150?
Pretty sure we did. Yes. Let me go through it one more time. So if x equals 1, remember we thought about, well, can I simplify the terms? But if -1 is so simple, I just pop it in for the x's.
Exactly.
So -1 to the 4th is going to be a +1. -1 to the 3rd is going to be a -1, except it's a negative, so it'll be another +1. So that's 2. And then the final one will make it a +1. That equals 3. So 3 up above. And then -1 minus -1 is -2. So it's 3 over 2, but negative.
Okay, good.
All right, 151. Your toy store. Okay, so the lowest possible price, if their range is from 20 to 40%, I'm going to assume that their lowest is going to be at 40 when it's at 40%, and then you add another 25%. So what would be the lowest possible price of a toy discounted costing $16 before any discount? So I'll take 40% of that. 1.6 times 4. That gives you 9.6 after the 40% deduction. Now I'm going to
Okay.
do 25%.
Now at this point you might be able to approximate.
Really?
Well, because it's a hard multiplication to do 25 times 96 or 75 times 96. So what's a quarter of 10?
I got 7.2. So, all right. So I went through the whole problem and got 7.2, but now you want me to do an approximation. So go ahead and explain it to me.
Well, so you did this multiplication, 25 times 9.6. You just did it manually?
I did.
Okay. There's nothing wrong with that. Here's what I would do. I would say, well, I see a lot of difference between these numbers, so I don't have to be exact.
Okay.
So a quarter of 10 is 2.5.
Okay. So we're going to approximate the 10 and take a quarter of 10.
Mm-hmm.
Yeah, it's 2.5, and then you subtract it and you get 7.1, which is
Now I guess 7.2. Since I wasn't quite at 10, I was at 9.6.
oh, so you go back to using 9.6.
Well, you just know that we got to be close to 7.1. And there's only one answer close to 7.1. That's not a big thing. It probably saved me 10 seconds over multiplying 9.6 by 0.25.
Yeah. Okay.
All right.
I like it. We got to get approximation minded. That's good.
I think probably in general it does help because so many of these, see, the moment I look for approximations is when I see problems like 9.6 by 25. I know that they never give you anything that hard to do because it's a non-calculator test. They just don't. I mean, at least it's very rare that there isn't a shortcut for doing that.
Okay. I'll grab another piece of paper here. So we have 152.
Right.
Okay, so they gave me x equals y plus 2 and z equals what? So I have z yards, y yards, and x yards. And I know that 24 equals 1/2 base times height. 24. In this case, the height is x and the base is y. So that's an equation right there.
Okay. Let's write out the equations we know.
Okay. I have 1/2 x times y equals 24, and I have x equals y plus 2.
And then we need to include z because they want to know what z equals, and we can see that it's got to be a number. It's not a function. In other words, z isn't going to be some number of x or y.
Right.
So how does z relate to x and y?
Z relates to the Pythagorean theorem.
Mm-hmm.
So x squared plus y squared equals z squared.
Now we have 3 equations and 3 unknowns.
All right. So first step I'm going to probably take is I'm going to plug in the value of x back into the the equation for area. So
Okay.
I'm going to have y plus 2 times y over 2 equals 24. Gives me y squared plus 2y equals 48. Y squared plus 2y minus 48 equals 0. Well, that's not helping me too much, I don't think. Okay, so y minus 8 and y plus 6 is going to give me 2. No, y plus 8 and y minus 6. So values for y are negative 8 and 6. And x equals y plus 2. Well, y can't be negative, so I'm going to say x equals 8, y equals 6. So 64 plus 36. 100, z equals 10.
Okay.
That sound right?
No, but you're close. I'm thinking about this problem as you do it, trying to figure out if there's any shortcuts, because it's pretty difficult to solve 3 equations and 3 unknowns. It's not that easy. It's very time consuming to do it.
And I was wrong?
Well, what's our most common kind of triangle?
Right triangle?
A 3, 4, 5. Right triangle.
Okay.
So I looked at this and I started wondering, if z is 10 and this was 6 and this was 8, everything would be perfect. X would be 2 more than y. This would be a 6, 8, 10 triangle. The area would be 6 times 8, 48 divided by 2, 24. In other words, I kind of found a shortcut without having to go through the gobbledygook of solving those 3 equations and 3 unknowns, which, like I said, is a long process. I wasn't following exactly how you did it. It certainly can be done, 3 equations and 3 unknowns. But this other technique wasn't a bad technique. It essentially was back solving.
But it was E, right?
Yeah. But you said 100z is equal to 10, which would have made z equal to 1/10.
Oh no. Well, what I'm saying is going through my mind. I had 100 within a square root, so it was 10.
Okay. All right. So you did solve the 3 equations and come up with 10.
Yeah.
It does highlight a problem, though. I mean, not a problem, but see, I truly think they did design this with the people who look for 3, 4, 5 triangles. Because if you're looking for a 3, 4, 5 triangle, obviously z isn't 5. That's not one of the answers. Doesn't make sense for z to be 6 or 8, but this 6, 8, 10 kind of is a clue. Z can easily be 10 if one of these was 6 and one of them was 8. And if one of them's 6 and one of them's 8, then x is equal to y plus 2, and the area is 24. So it's kind of a weird problem to try to back solve, but only because of the specialness of the 3, 4, 5 triangle is it a potential way to solve this problem.
Okay.
Okay, age problems. What kind of problems are age problems? Always?
back solving?
Yeah.
All right, let's give it a shot.
Before I even look at it, I'm going to back solve it when I see an age problem.
Okay. Let's see. Jack is now 14 years old. 10 years.
So work through the back solving out loud for me.
All right. I feel comfortable writing some quick little equations down, but let me see.
Well, this is such a classic back solving, Stephen, because it's one where you always are going to know which direction to go, which means you're going to have to check at most 2 solutions. And I would like you to do it just because I'm not sure you've fully worked one without my assistance yet. So, and you need to be able to. You want to be able to back solve on this test.
All right. So Jack is now 14 years older than Jack.
Go ahead.
All right. Let's say Bill's 1 year old and Jack is 15 then.
Hold on. I didn't hear your first step. What?
If I say I'm just going to start somewhere. Bill's 1 year old and that makes Jack 15.
No, that's picking numbers. That's not back solving.
Oh.
Back solving is where we pick an answer. In other words, how old will Jack be in 5 years? We're going to say 19. We're going to go with the second lowest. Okay, so in 5 years, Jack is 19. What's that make him now?
In 5 years, Jack is 19. That makes him 14 right now.
Okay. How old's Bill right now?
So Bill's 28.
Jack is 14 years older than Bill.
Oh, that makes, yeah, he's 0 years old.
Okay. If in 10 years, hold on 1 second.
Oh.
Hey, I'm in a session. Can I call you back? Okay, great. Talk to you later. Bye-bye. I knew it was something exciting. My son doesn't call me twice in a row unless it's something important. Okay, so if Jack in 5 years is 19 years old, and he's 14 years old now, Bill is 0. If in 10 years Jack will be twice as old as Bill, well, in 10 years Jack will be 24, Bill will be 10. That's not twice as old.
Oh, wait. You just jumped to a different number?
No. In other words, when I'm back solving, I'm picking an answer, and then I'm seeing if everything fits with that answer. And it doesn't. Because if Jack, see, here's the premise with back solving. You have to assume that 19 is the correct answer. If we assume that 19 is the correct answer, then currently Jack is 14, Bill is 0. In 10 years, Jack will be 24, Bill will be 10, and Jack will not be twice as old as Bill.
Okay. I was going to say that was wrong just because Bill was 0, but I guess...
Well, that doesn't necessarily have to be wrong. He could be 0. But, okay, so we know that that's not correct. 19 isn't correct. And do we know whether Jack needs to be older or younger?
Well, I guess he needs to be older.
I think younger. Let's see. Let's just try 9 real quick. Okay, how old will Jack be in 5 years? If the answer is 9, then Jack is currently 4 years old. Bill hasn't been born yet, so Bill is -6, but there's absolutely nothing wrong with that. And now in 10 years, Jack will be 14 and Bill will be 4. I still more than twice as old. So you were right. You got to go the other direction. So we're going to go to 23. In other words, this wasn't exactly clear which direction to go. Usually age problems are, but this is a little different. So if Jack is 23 and 5 years, Jack is currently 18 years old.
I'm going to try this one out. Let me see. So if Jack is 20, we're going to assume he's 23.
Okay.
And this is 5 years in the future, so we subtract 5, and now you get that 18.
Okay.
So that means that Jack is now 14 years older, so that makes Bill 4 years old right now. So in 10 years, Jack will be 28 and Bill will be 24.
No, 14.
I mean 14, I'm sorry. That works.
And that works, exactly.
All right. Would we know to go up or down this problem? No, not really, but...
Oh, are you talking about 153? I wasn't positive whether to go up or down. The only reason I went down is because that's a nice low number and it didn't take long to check. Although I did do my math wrong now that I remember doing it. I needed to subtract 14 years from that. And notice that it doesn't matter if Bill is a negative age, because the problem states that Jack's 14 years older than Bill. So as long as Jack is 14 years older than Bill, that is the only thing that matters. Okay? In other words, we couldn't rule out that 19 because Bill was 0 right now. Maybe he was just being born. I don't know.
Okay.
All right, a work problem.
Yeah. Okay. Takes 8 hours to fill 3/5.
This isn't really a work problem. This is a straight algebra problem.
I don't. For some reason I'm not.
Okay, well, let's try to figure out how long it would take to fill the whole pool. In other words, I can make a ratio. 8 hours is to 6/10 of the pool, as X is to the whole pool.
Where'd you get the 6?
3/5 is 6/10. I figure it would be easier to represent that as a decimal than a fraction. In other words, since it's filling it at a constant rate, I know that this ratio is correct. It's going to take 8 hours to fill 6/10 of the pool, then it would take X to fill 1 of the pool. So X is equal to 8 divided by 6/10. $13.33 hours to fill the whole pool. So how much additional time does it take? If it takes 13.333 hours to fill the entire pool,
I would have had issues with that decimal division going into 8.
well, notice I didn't pay any attention to the decimals up here. It's all I knew that when I divided 8 by a number less than 1, it had to get bigger.
Okay.
So I know the answer isn't 1.3, and it's certainly not 133. So the ballpark check is 13. In fact, I'm dividing by a number close to half, so I would expect the answer to be around 16 or 15 or something like that. So I know exactly where to put the decimal point.
Okay.
Now, you can go through the proper way to handle the decimal point, but if you're like me, when you finish, you're going to do a ballpark check just to make sure you didn't make a mistake. And I did that my whole life, and finally I realized, well, why go through the initial part if I'm going to do a ballpark check anyway?
Right. Okay. So now we got 13 hours minus 8, pretty much.
Okay, so what's our answer? Because it's still not completely clear.
5.3.
Is that an answer?
No. 1/3 of an hour is 20 minutes.
All right.
So, you got to be careful there.
Yeah, it'd be easy to say 5 hours, 30 minutes, given the answer we got.
Right.
So they definitely put the trap answer on there.
Yeah, I got to be careful. Okay. See, I knew there was a proportion there, but I just didn't know to write it as 8 over 0.6.
Yeah, whenever you're dealing with a constant rate, then we know that, well, one way to look at it is, suppose it had been a little easier. Suppose they'd have said he filled half the pool in 8 hours. You would have known instantly that it would have taken him 16 hours to fill the pool.
Yeah.
And that is arrived at by that same formula. So sometimes if you do problems with easier numbers that don't result in fractions, like 8 divided by 0.6, it gives you a clue as to how to set up the ratio. Or if he'd have filled 1/3 of the pool in 8 hours, you'd have known that 24 has to be the answer. And the way you get that would be 8 divided by 1/3. Oops. Okay, number 155. Two ways to do this.
So I wrote it out algebraically.
Okay, nothing wrong with algebraic, but it's worth noting that it's also very easily done with back solving. Because they give us a number, we can just plug that in and start going through everything.
Okay.
So what's your equation?
Got a square root of 2x over 3 equals x.
Okay, so now you got to solve it.
Yep, and so
How do you solve this? What's the first step?
well, actually, after I wrote it out, I was inclined to just start plugging in the numbers.
Oh, okay. So then you back solve it. All right, that's essentially what I would have done. when in back solving. But I think it's important that you know how to solve this equation also.
Okay, so let me get rid of the square root.
Okay.
Get x squared.
So 2x over 3 equal x squared.
Yep. Multiply by 3 both sides.
Okay, so now 2x equal 3x squared.
Divide by x.
Okay, that's okay in this problem because there's no 0 as an answer. That's in general a dangerous step to do, but it'll actually work pretty easily here. It's a good shortcut.
2 equals 3x. X equals 2 over 3.
Right. So algebraic actually was pretty quick. And algebraic has one definite advantage here. And that is these numbers are difficult numbers. They're not whole numbers, they're fractions, which means it might be difficult to multiply them by 2, divide them by 3, and then take the square root of it.
Yeah.
So this might actually be a problem where the algebraic solution unfolded much quicker and being able to take that shortcut. Notice what that shortcut did. You lost one of the solutions. One of the solutions is 0.
Yeah, I don't even know what that means. I just gotta do it. Why is that dangerous to do?
Because you can't divide by 0, and if x equals 0 is one of the solutions, you're going to lose it when you divide by x. Notice that the only solution we came up with was x equal 2/3. And yet, clearly, if we look at this, 0 works for x, or this, or this. But 0 wasn't on there, so it was okay to take that shortcut.
Oh, wow. I like that point. Thanks.
It's a little bit esoteric, but comes up more in trig than it does in calculus or algebra and geometry.
Okay. So it's originally has the amount of chloride in it is 0.05 times 10,000. But then you're losing 2,500 gallons. So I'm just going to get that amount, that volume right there.
I think that's correct. You always want to do these kind of problems like that. Let's figure out how much sodium chloride is in that thing. So what's a quick way to do 5% times 10,000 gallons?
I took 10% of 10,000, which is 1,000. It's 500.
Right. That's
So
nice. That's a nice shortcut. You don't have to worry about decimal points or zeros or anything. So now what's the percent of the final thing going to be?
The remaining solution will probably be what percent? Okay. So it's going to be 500 over 10,000 minus 2,500. So that equals part over whole, so that's what gives you a percentage, right?
Uh-huh.
So what percent is 500 of 7,500?
Okay, and cross those zeros out. You can divide top and bottom by 5. What's the answer?
Wait a minute, why are you getting 1 over 25?
Because 5 over 75 is 1 over 25. I divided top by 5 and bottom by 5. Oh, excuse me, it's 1 over 15. I made a mistake in my math. Thank you.
1 over 15. sodium chloride 1. So that's the percent that's in.
That's the fraction of the final gallon solution that is sodium chloride, 1/15th of it. So what percent is 1/15th equal to? In other words, convert this to a decimal and then convert it to a percent.
15. I guess it's 10. It's just 0.15 times 100. Oh.
So all we need is the number. The decimal is going to take care of itself, right? You don't need to worry about the decimal place. First of all, the first number here is 6. So it's one of these two answers. So all we need to do is figure out the second number and we're done. Second number is 6 also. D has to be the answer.
Yeah, no, I don't get that. So I would have got lost there a little bit. I can follow you as far as put the part of chloride that we have, which is 500, over the new total volume, which is 7,500.
Okay.
And that gave us 1/15. So that 1/15 is.
Convert that to a decimal and then convert it to a percentage.
Okay, but why 15 over 100?
It's 15 divided into 1. I can't divide 15 into 1, so I have to add a bunch of zeros after it.
It doesn't matter how many, you just add whatever you want?
Yeah. Like I said, we are not going to have difficulty figuring out where to put the decimal point. None of these has 60% as an answer. We know it's not 60% anyway. So the only numbers we have to get are the first two numbers. If we can get the first two numbers, we will have our answer.
Yeah. I gotta stop worrying about that, huh?
Yeah, don't worry. You'll never have to know where, well, I shouldn't say never. Sometimes you have to know how to figure out that decimal point. But, I mean, the way I would do it is 1/15th is between 1/10 and 1/20th. Well, I know 1/10 is 10%, and I know 1/20th is 5%, so it has to be somewhere in between those two values. So that takes care of the decimal point right there. But
10% is 1/10 equals 0.10. 50% is 0.5. Or no, 0.0. 5%
is 1/20th.
Oh.
In other words, when I'm doing the problem, I want to know my ballpark right away. So if I'm trying to figure out what percent 1/15th is, and I know what 1/20th is and 1/10th, then I know 1/15th has to lie in the middle. It has to be between 10% and 5%. But I don't even have to do that with this problem. I can tell that this problem, the answer, the decimal point's the same with all these numbers. So the only thing I have to get is the first two numbers. And I get that by dividing 15 into 1 with however many zeros I need to put after it.
Yep.
I mean, technically, the decimal point goes right there, and I had to add 2 zeros to make my first division, so it's going to translate to 0.0667 is the answer. But
that's fine.
Spending all that time is a wasted amount of energy. You don't need to do it.
Okay. And let me recap here everything that we did. So we gave us a total tank, and they gave us percent of that volume. So we found the total of chloride in that first set of volume. Then we took that didn't evaporate, just the water did.
Mm-hmm.
So we just subtracted the 2,500 from the 10,000 and put our total chloride over our new volume. That gave us a fraction. we then had to convert a fraction to a decimal point, then multiply by 100 to get a percentage.
Once you get this, you've got the problem 99% solved.
Yeah. Well, that 1/15th gave me an issue for whatever reason.
Well,
because I expected that to be kind of like the last step, I guess.
You didn't need to convert it to 1/15th, first of all. Let's talk about that. I mean, it is very important here to realize that you are not going to have to worry about the decimal point, and that is the reason we look at the answers. Okay? Is because maybe they would have had a 6.67 and maybe they would have had a 66.7. Well, then I'm going to have to worry about the decimal point. But I can see I've got 5 different sets of numbers here. So all I have to do is divide 75 into 5. And I'll also get the answer. The first number will be a 6. That will tell me conclusively that the answer is either C or D. And then if I finish this multiplication out, I realize I get another 6, I'm done. So it might have even been a wasted step to convert this to 1/15th.
Oh, I see.
Just go ahead and do the straight division to get these first 2 numbers.
And tell me about that trick one more time. You see 2 zeros in both the numerator and denominator, you just say, I'm simplifying that, making it 5/75, right?
Yeah, for sure. That's the first step. And then I'm looking to see, well, does 5 divide into 75? And yes, it does. So as long as you can do that quickly, it might make this step slightly easier. Although, I don't know. It does. It's easier to divide 15 into 100 than it is 75 into 500.
Yeah, you're right.
So it helps a little.
Now, 157.
Okay.
For any positive integer n, the sum of the first n positive integers equals. So is n the number of integers between 99 and 301? That's the way I'm reading it.
Yeah, between the even integers. And that's going to be a tricky part to this problem. Is we're looking for the even integers.
Oh, man. Well, I guess that assumes that it's gonna have the numbers have to be between 100 and 300 because.
Right. Look at our answers. Our answers are there's a lot of disparity between the answers. We've got a 20,000 and a 22,000. And we got a 40 and a 45. But other than that, we can probably get by with a relative approximation here, maybe. I don't know. Let me ask you this. What are the sum of the integers, all of them, between 0 and 99? Or, I'm sorry, between 1 and 99. What is the sum of those integers based on this thing here?
Be 100 plus 1 times 100 over 2.
Between 0 and 99, so n would be 99. So it would be 99 times 100 divided by 2.
Don't you add 1 when it's inclusive? Like the 0 would be a number to add to 99?
The first n positive integers. So n starts with 1.
So
we're not going to do 0. And
is 0 a positive integer or not?
no. It's an integer, but it's not a positive integer. It's the one integer that's neither negative nor positive.
Okay. So that was kind of maybe.
Mm-hmm.
Okay.
Okay. So if this represents the sum from 1 to 99, and what represents the sum from 1 to 301? Mm-hmm.
Times 302
Mm-hmm.
over 2.
Okay, so now conceptually we have a better grasp of the problem. Because, first of all, the sum of the integers between 99 and 301 would be the difference of these two.
Yeah.
And we can safely assume that half of that is going to equal the sum of the even integers. Even though it might not be precisely exact, it's going to be close enough for us.
Because of those numbers, yeah.
Yeah, there's at least 2,000 difference between all these numbers. So whether we're off by 1 or even 10 isn't going to matter.
Yeah, okay.
So, in fact, the sum of the integers is going to be half of this. So let's come up with an approximate value for these things. What is 99 times 100 divided by 2 approximately?
You get 4,500, we could say.
Well, if I'm going to approximate it, I'm going to let this be 100. And now I have 100 times 100, which is 10,000, divided by 2 is 5,000. So let's just approximate it by that.
Approximation, that's right. So now 300 times 300.
Okay, but that's all the integers, remember. Let's not lose sight of the fact that we only want even integers, but that's okay. So this is all the integers from 1 to 99 is 5,000. And then this one here can be approximated by 300 times 300 is 90,000, right?
Yep, over 2.
4 zeros, because there's 2 zeros there and 2 zeros there. So that's approximately 45,000. So the difference between these two numbers is 40,000, but they want even integers only. I'm going with answer B.
That's a good problem.
Yeah, it is. It is. And still not 1,000% sure that answer B is correct because we did approximations. But let's see. And there's a possibility that C could be correct because this 5,000 is overestimated and this 45,000 is underestimated. So conceivably, if we actually did this math, let me do that math here. Let's just see. It's 301 times 302 equals 90,902. So this is actually 45,451. And this is actually 99 times 100 is 9,900. So this is actually 4,950. And so now if we take the difference between those two and cut it in half, we still don't get up to 22,000 anywhere close. In fact, this is the exact answer.
Okay.
Okay. I guess the key here was they didn't give us a formula to go from 99 to 301. They did give us a formula to go from 1 to 99 and from 1 to 301. So the first critical step was breaking the problem up into two things, knowing we're going to subtract these two numbers from one another to get the sum of the numbers from 99 to 301. Would have been a hard enough problem if they'd have just said all the integers, let alone the even integers, added an extra step of difficulty into it.
For any positive integer n, the sum of the first n positive integers equals.
He was actually a famous mathematician. When he was 8 years old, his math teacher asked the class, what are the sum of the numbers from 1 to 100? And he came up with the answer in 10 seconds. And he did it, well, because he figured out how to do it. I don't know that he necessarily used this formula. That's the correct formula. But what he did was he looked at it as a series of numbers up to 100. Well, if you want the sum of those, if you're looking in the middle, I know that this and this adds to 100. I know that 48 and 52 adds to 100. So using that principle, there's exactly 50 pairs of numbers that add to 100 plus one more. And that's 50. It's the only number that's not included. So our answer has to be 50 pairs of numbers that add to 100. That's 5,000 plus that last number in the middle, which was 50. So that's the answer of the sum of the numbers from 1 to 100. And it also, if I plug it in there, I get 100 times 101 divided by 2 is also equal to 50/50.
Okay, can you explain to me one more time how to use that equation? When I read for any positive integer n, the sum of the first n positive integers equals n.
Okay. Let's say what's the sum of the first 10 integers? 10 is n. So the sum of the first 10 integers would be 10 times 10 plus 1 divided by 2.
Okay.
So whatever n is, you just plug it in there, and that's what the sum of the first 99 integers would be.
And in this case, they say, what is the sum of 99 and 301? But obviously between, but we know that it's two steps then, so it's 99.
Exactly. It's a subtraction problem. It's kind of like the shaded area.
Yeah.
If I say, what's the shaded area? You don't figure out the shaded area. You figure out the area of the outside circle and subtract the area of the square to get the shaded area. Well, this is a similar kind of problem. It's a subtraction problem because we don't have a formula that gives us the sum of the numbers between 99 and 301. If we did, they didn't give it to us. They gave us the sum of the numbers from 1 to this number. That's what this formula is. This is definitely a harder problem just because it deals with arithmetic series.
But it's very doable. So a problem like that is what I need to capitalize on a problem like that because that may well be in the hard bin. And that
yeah, I think as long as you understand this part here, you'd figure that out. If you automatically knew that, well, the way we get 1 to 99 is to plug in 99 for n, I think you could figure out the rest of it.
All right.
So you do have to understand that we frequently have things like going from n equal 1 to n equal 99. The sum of that is going to be expressible as this.
Okay.
Okay. Okay.
158, and now what are we working with here? Committee. So more than likely they're going to ask, oh, no, it's probability. Let's see. Committee.
Oh, we don't have the answers here. Let me, I think they're on the next column. Let me just take a, oh no, they're on the next page. Let me pull up the next page so we get to see the answers. That's kind of a weird way to do it. All right. So the answers we're looking for are all in variables. Hold on. There. These are our answers.
Oh, I see. Okay. Okay. Let's see. So that's always crucial to look at.
Yes, because we're not looking for a number. We're looking for a function of W and M.
Okay. So let me reread this. So a committee equals W plus M.
Mm-hmm.
Just to start there.
Okay.
And then say we add 3 women and 2 men.
So what's our total people now?
As far as we can see, the total is 5.
No, it's W plus M, because those are numbers. We just don't want to know what they are,
Okay.
plus 5.
Oh, but see,
Because 3 women and 2 men were added. So in other words, if there were 10 women and 15 men, we've added 5 people. So this is the total. Probability is always the success divided by the total. So how many women are there on the committee after we added 3 women and 2 men?
W plus 3.
Divided by the total. That's the answer we're going to look for. Jeez, how many times do I have this open? Wow, look at that. It messed up. Okay, that answer is on there. It's E.
Jeez. See, what upsets me is I don't see that initially, and I'm not getting there until you tell me, and that's the problem.
Well, the key here is really looking at the answers, because when we look at the answers, here, let me see if I can fix this here. I don't know what's happened. My computer kind of went kablooey here. If we look at the answers, these look like probability results. We have something divided by something else. Well, that's the way we show probabilities.
We show probabilities by what's over what again? In the numerator we
The
have...
definition of probability is probability equals the number of successes divided by the total number of events or opportunities. So in our case, we're going to take the number of successes, which is equal to the number of women, divided by the number of people. So that's what we're looking for when we're done. That's going to be the probability, the number of women divided by the number of people. Now we have to go back and see if we can put function values on all of those. Well, it's pretty clear to see the number of women as W plus 3. The total number of people started with W plus M, and we added 5 people.
So that was the way of looking at it. It's just what's the total women and what's the total people. Once you
Exactly.
get to that notion, you know that it's W plus M plus 5 and over W plus 3.
Right, right. And actually, that's a fairly straightforward problem there. I would say that that's medium to easy degree of difficulty. The key is knowing what probability means.
Do we want to jump into data sufficiency?
Yeah, sure. Let's see. We got through.
Go grab some water.
That's not the alarm for that. I have a 10 o'clock alarm set on there every day. So we got through 158.
I'm going to grab some water. Is that all right, Dave? I'll be right
Sure,
back.
sure.
All right.
Okay. 121. This was this problem that kept giving me difficulty. And the only reason it did was because I didn't draw my curves correct the first time. So it is relatively important. The key to answering 121 is drawing the curves correctly. And if you make a mistake, it's going to be deadly.
Okay.
The first curve, the one that was in the stem, had a y-intercept of 2, and it had an x-intercept. If we let y equal 0, then x is equal to 3, so it had an x-intercept at 3.
Sure.
So here was the first curve. And I'm going to label this the stem, because that's the part that's fact for sure, and we know that the area we're looking for is less than that. Okay, so now we look at the second curve, and we need to know its intercepts. Well, if r is the equivalent of the x, so I can label this r and this s, or I can label this x also and this y. So for the second curve, for me to draw this, if I want the r-intercept, I set s equal to 0, which gives me r of 2. And if I want the s-intercept, I set r equal to 0, which gives me an s of 3. So this curve is like that.
Yep.
So now I can certainly see that there are points on r and s that are above and below the stem curve.
Yes.
Okay. So now taking the second one, if r is less than 3, it could be somewhere in here. But s is less than 2. Well, all of these points here, r is less than 3 and s is less than 2.
I can't see what points you're looking at because I don't see your...
I made an X right there.
Okay.
Okay? So there is a point based on number 2 where r is less than 3, s is less than 2, and yet I'm under the stem. In fact, based on number 2, any r that's less than 3 and s that's less than 2 doesn't necessarily work, because what if I pick an r right here and an s right there? R is less than 3, S is less than 2, but I'm on the other side of that curve.
Yep.
If I pick an R less than 3, S less than 2 right there, I'm on the opposite side of the curve. So that alone doesn't work either. I didn't pay any attention to this other line here that is this line here is stem number 1 or point number 1.
Right.
So now to figure out, can I draw points on either side of this thing using both? Well, it has to be on the line, has to be on the number 1 line. So clearly I can. There's a point right there. And this is solving it graphically, not algebraically. In other words, see this point right here?
Yep.
R is less than 3, S is less than 2, and I'm on that line.
Yep.
Well, this point here, same conditions. R is less than 3, S is less than 2, I'm on that line, I'm on the opposite side.
So neither.
Neither.
Okay. I see.
And some problems, I think, can be solved graphically better than algebraically. And for me, this is one where as long as I draw a relatively accurate picture and I can disprove each situation, in other words, I can prove that I can be on either side of the line with their information, then it's not enough information, clearly.
All right.
All right. Finally, we got a handle.
Yeah, we got that one solved.
Yeah, really. I don't know. I had 2 different epiphanies on it, and
It looks good now, though. It's just, I guess that's what it was, is keeping a real good track of it all.
yeah.
Okay. What is the volume of a certain rectangular solid? Okay, so it's 3D, and we want the volume. Stem 1. 2 adjacent faces of the solid have areas 15 to 24 respectively. Okay, so they definitely share a height, but they don't. One has a width and one has a length. So what is the volume? Let me see if I can solve for that and pick some numbers, and maybe one's exclusive.
Hold on. Let's we've drawn our figure poorly, but let me erase this line here. Okay, so there's our rectangular solid. And they're saying the 2 adjacent faces have areas, not volumes, but areas of 15. So that would have 15, and that one would have 24.
Right. Now, they obviously share a height, is what I was getting at. They share a height.
Right.
So that's one less thing we would have to try to figure out. But they differ in, let's say, length for 24, the 24 area, and width for 15. So we don't know the height, the length, or the width, but we know they share the h. So h times L equals 24, and h times W equals 15. Can I solve that?
Good thinking. You're on the same track that I was trying to get to. In other words, in my drawing, I've got xz equals 15 and yz equals 24. Do I know what x times y times z is, which is the volume of the solid?
I'd say no.
Right. Let's see.
But the thing of the GMAs is they're tricky. There's sometimes a way you can set it up.
Let me think for a moment here. I think because we have three variables, there's no way, but let me just think for a second here. So x is equal to 15 divided by z. So now x times y times z would be 15 divided by z times y, which is 24 divided by z, times z equals volume. Well, one of these z's cancels, but the other one doesn't. So volume is definitely a function of z, and we don't know what z is.
Oh, okay, so you plug in the volume and solve something interesting will happen there.
Right.
Oh, I didn't even think of that step. So that'd be an option too, because you never know. But I haven't been able to see how you're gonna get three answers with two equations yet.
Right. So we'll assume one is a no.
Okay.
Let's look at 2. Each of two opposite faces of the solid has an area of 40. So we could say xz equals 40 and yz equals 40. Does that change anything? X is equal to 40 over z. So we would have 40 over z times 40 over z times z. We still are going to have z squared in the bottom and a z in the top. We're still going to need z.
Yeah, 2 definitely doesn't solve it. But now when I look at it together, now I'm even more confused because two adjacent faces, it necessitates that the bigger one is going to be 24. So what two opposite faces have 40? In a rectangle.
Two adjacent? Ah, you've hit upon something. You've hit upon something. I'd be inclined, if I had to finish the question right now, I'd be inclined to say both of them solve it. But let's look at number 2 a little bit more closely. If two adjacent faces have the same area, they have to be the same dimensions.
No, because it's a rectangular. They'd be different.
Well, a rectangular solid can still be a cube.
Oh, really?
Yeah. The question is can we draw a rectangular solid where two faces have the same area, two adjacent faces have the same area if we use rectangles? So if we use a rectangle, okay, yeah, I could say that this has the same area as this, and it's a rectangle. So this would have to be x, that would have to be y, and this is clearly x, which means this also has to be y. So the volume of this thing is now x times y squared. Just two variables. In other words,
40 times y.
So two of these equals, this is the total volume of the area. X times y squared. We might be able to solve it with just this 2 alone. Let me think for a moment. If x times y equals 40, and xy squared is our volume, no. If x times y is equal to 40, then y is equal to 40 over x, and our volume would be y squared. Our volume would be x times this squared. We still have an x left in the denominator. We can't tell what the volume is. So with 2 alone, we can't tell what the volume is. And if we're taking the test at this point, I would a long time ago gone with both.
Well, the thing, if you say both, it kind of doesn't make sense to me then. Because if each of the two opposite faces are an area of 40.
Oh, wow. You just pointed up something. I misread the second one. This is two opposite faces. This is two adjacent faces. Two opposite faces having the same area means virtually nothing, right? In other words, if I look at the two opposite faces here, this front face and the back face,
we always know that
they always have the same area. It isn't always 40, but it's the same area. So we can definitely say xy equals 40, and if we combine that with the first one, that's definitely enough information. First of all, it tells you that if the opposite faces each have an area of 40, then the two adjacent faces they're talking about have to be this one and this one.
Yep.
This would have to have an area of 24, the top, and the side would have to have an area of, say, 15. And then the front would have an area of 40. So if we know the area of 3 of the faces, we can certainly figure out the volume of it, because we're going to have 3 equations and 3 unknowns.
Yep.
Okay, and let's just add one thing there, just to make sure you see that. If I know the area of 3 of the faces, and I do, it's got to be 15, 24, and 40. That means that xy equals 15, xz equals 40, and yz equals 24. There's my 3 equations, 3 unknowns. Yeah. I have to be able to solve for x, y, and z, and then the volume is x times y times z.
We know that on a deep level, so that's not even worth our time.
You're right. That was my intuition, but that's the mathematical proof of it.
Okay.
All right, let's go to the next one. There's certainly the trial and error method of solving this, but that's going to take a long time. So I wouldn't recommend that. Let's see if we can set up some algebraic equations.
Yeah, I set up 0.15x plus 2.9y.
I like it. Plus 0.29y.
Yep.
Equals 440.
Right. And then I started thinking in my head, I started messing around with, if I start adding 15s together, I'll always get 30s, 45s, 60s.
Okay.
And then...
you're on to something, because initially I would say, well, we can't solve for x and y with one equation. But we actually have more information, and that is that x and y are positive integers. So it's quite possible that there is only one unique solution to this if x and y have to be positive.
Right.
And in fact, we can see that 15 plus 29 adds to 44. So certainly one solution is x equal 10, y equal 10.
No kidding.
Question is, are there other solutions? And maybe not. I'm not quite sure how to completely determine that. But I think you were on to it. When you take multiples of x, you're always going to end up with a 5 or a 0. But it's the multiples of y that are more interesting. Because multiples of y are going to end up with a 9 unless y is 5. So the only other possibility, in other words, notice that y's other than 5 or 10, you're going to end up with a 9 somewhere, not a 0 as the last digit. So the other y I might be interested in trying would be y equal to 5, because that makes that number end in a 5. And this has a possibility of ending in a 5 also. So 5 is the only other y I really have to investigate. And 5 times 29 is $1.50 minus a nickel. So this would be $1.45 if y was 5. And now can I make this equal the difference, $2.95?
I think you can.
X divided by, would have to be divisible by 15, and it isn't. Because I know 15 goes into 30 perfectly, so there's no way it's going into 295 perfectly without doing the math. I know that this will not equal an integer.
So that's not so. For that, we just tried another unique solution, but we haven't found one so far.
Well, we didn't find another unique solution. And the only ones that we need to try have a y of 10 or a y of 5. Notice that if we use any other number for y, let's say we tried a 3, well, 3 is going to produce a last digit of a 7.
Yeah.
There's no way 7 can ever add to 0, because it would require this last digit to be 3, and that can't happen. So this is actually a really good problem. I think 1 alone answers it.
Yeah, it looks like it.
The only other y to try would be 0.
So we tried 5, 0. We could even try 15. If we did 15 times 30,
Correct. We could.
it'd be over. It'd be 45.
Right. Well, hold it. 15 times 29 is $2.90 plus $1.45. So that would be $4.35. And you're right. There's no way to make up that extra nickel with 15-cent stamps. So a y of 15 doesn't work. A y of 5 doesn't work. A y of 0 doesn't work. 15 also doesn't go into 440 an even number of times. Because I know it goes into 450 an even number of times. It can't go into 440 an even number of times. So the only solution is y of 10, x of 10.
Yep. That's it. There's only one solution.
This is a special kind of problem because the other piece of information is that x and y are positive integers. And even though that's not an equation, it's enough information to give this only one solution.
So you're talking about number 2 now?
No, I was still looking at number 1. Let's look at number 2.
So number 2 says there's equal number of stamps, so you make them x, well, make them both x, and it pretty much does the same thing that we just solved, is that you'll figure out that they're going to equal 10 and 10. So,
well, if it's an equal number of stamps, then I can use x in place of y. So it's 0.15x plus 0.29x equals 440. Factor out the x. I'm left with 0.44. Yes, that's enough information to solve for x.
and see, they would, you really, wait a minute. No, because we can't use 4 That's part of statement 1.
Very good. You're right. You're absolutely right. So statement 2 can't possibly solve it if we don't know the value, because it could be 20 and 20 or 30 and 30 or 7 and 7. So you're right. Without statement 1, we can't solve statement 2. Problem's over. We don't have to consider both.
But how funny that they give us a clue and a pitfall in the same thing.
I do that all the time. It's one of the main pitfalls of the GMAT, data sufficiency. You almost have to write it on the back of your hand. Once you've considered 1, when you are considering 2, do not consider 1.
Yeah.
I have a real hard time not making that mistake.
All right.
All right.
Let's see.
Let's go to the next one. Let's see. I got to go to another page here. 284. That was a good problem. That was tough, actually. It's tough to come up with the fact that number 1 alone solved it. Okay, 124. Oh, these problems. Table problems. These are basically Venn diagram kind of problems, only put in table form instead. I'll tell you right now, I'm not real good at these. You can see, first of all, why you can't answer it from the stem, right? You can't just add 40 and 30, because there may be some overlap.
So at least, let's just take it one step at a time. So 1 tells us that at least 60 of the 100 responded in some number of voters who did not respond favorable. So at least 60 people responded favorably with favorable.
Favorable for at least one candidate.
Yeah, we don't know who. Okay. And what does that tell me? So candidate M got 40 and candidate N got 30. So somebody, a certain amount of people must have gave more than one person favorable. There's 70 favorables and 60 people who gave at least one. Somebody, at least in this case, at least 2 people, at least 10 people.
Okay, this is the favorable, this is the unfavorable, and this one is the not sure.
Never seen.
There's 100 people. So this, boy, this is tough. This would be, this area here would be F plus U. In other words, the only thing I know is that 100 is equal to the whole areas here. There's 2 candidates, so it's hard to use a Venn diagram. I don't know. It doesn't feel like one alone can possibly solve it. So all we know is that 60 people voted favorable for at least one candidate. I don't think we can figure out how many people voted favorable for both candidates on that information.
Well, if there's 70 total favorable votes,
Mm-hmm.
and only 60 people responded.
No, at least, let's see, the number of voters who did not respond favorable for either candidate was 40.
That means that 60 did favorable for at least one. And so there's 60 favorable votes.
Right.
That means there's 10 unaccounted for, which means at least 10 people voted twice favorably.
Ah, you're onto something there, I think.
Voted favorably.
If we know that 60 people voted favorably for at least one, and we know that there were 70 favorable votes, then there has to be exactly 10 people who voted favorable for both. We had 60 either one favorables, or some of those 60 could do 2 favorables. Since we've got a total of 70 favorables, I think that does tell us that 10 had to vote both favorable.
And there's no other way of getting there. So I mean,
right. So I think 1 does answer it.
Okay. Number of voters who responded unfavorable for both candidates was 10.
Which tells us that 90 voters didn't do that.
90 voters didn't do that, but that doesn't mean they could have not voted unfavorable at all, or they could have just voted unfavorable.
They could be not sure. Oh, let's see. Who responded unfavorable for both candidates was 10. So we can get some information out of that.
So 55, 10 of those, so 20 minus 55 is 30. So 35 votes came from single people. So 35 people voted on
This
favor.
not sure category is what's going to screw things up, I think. No, maybe not. Let's see. because we know exactly 10 people voted in common here, which means there had to be 45 people who voted 1 unfavorable, which says nothing about whether they did the not sure or the favorable of the rest of them.
At this point, I'm going with A and moving on. Can we check the answer?
I don't think we can. I'll try here. I got some of these, but I don't have all of them. Just a second here. I got to open a new thing here. This is what, 124?
Yeah. Yes.
Data sufficiency answers. I go down to only ones of these that have bytes are this one. So if it's not on this page, no. I got answers once we get to 133, but not prior. These answers are up to 121. So I'm missing answers from 121 unless, no, this isn't it.
That's all right.
Well, hold on. I got one other thing that says answers. I might have a final answer on this, and that's this answers here. What's this going to be? Those are answers to problem solving, but not until we get deeper into the problem solving. Yeah, starting at 186. All right, I guess I don't have answers up to 132. So let's go on.
Okay. I'm going to just go on to 125 here.
Yeah.
So you have 3 different types of operations: addition, subtraction, multiplication. And I have this equation. And is that true? That equation true for all numbers k, l, and m, depending on what operation we use. In STEM 1, k to the 1 is not 1 to the k for some numbers k. So that is gonna lead me towards multiplication.
It appears to be multiplication. In other words, multiplication works if k multiplied by l plus n is certainly equal to k times l plus k times n. So it could be multiplication. Could it be addition? K plus L plus M not be equal to K plus L plus K plus M unless K was 0.
But here's the thing, with STEM 1, K plus 1 is not equal to 1 plus K. K could be a negative number, so it wouldn't be. So
well, that tells you it's not multiplication. Because if this dot meant multiplication, K times 1 would have to be equal to 1 times K. There would be no values of K where that wouldn't be true.
Yeah, so it's multiplication.
No, that tells you it's not multiplication.
Why?
It's not equal.
Oh, it's not equal.
Right. So it's either got to be addition or subtraction.
Jeez, it's not equal.
Could subtraction be right? Let's try subtraction. Pi, shh.
Gotta write this out because this will get too confusing.
Is this a true statement? We end up with K minus L minus M. Is that equal to K minus basically 2K minus L minus M? So the only thing that would make that true, and this has got to be true for all numbers K, L, and M. So since multiplication was the only one we came up with, and 1 didn't answer it, ah, 1 does answer. No, it doesn't. Let's look at 2.
Number 1, subtraction seems to work.
How so? I end up with k minus L minus M equals 2k minus L minus M, which would mean k equals 2k.
Well, I got, let's see where you did. K minus L equals K minus M. Can't you factor out a K and call it K parentheses?
No, you're not multiplying. You can't factor out a K over there, but you can certainly combine the two equations to come up with 2K minus L minus M.
Oh, you can't? There's no multiplication, so you can't
No,
factor anything.
no. So this equation would be what, if we look at item 2 alone, it might be worth, hold on one second. It's the garbage truck. The garbage truck set off. If that represents subtraction, like number 2 says.
Okay. Now we've already
notice the word I've been missing this whole time is this is. Is that equal to that for all numbers k, l, and m? Does 2 answer the question? It does. It's not equal to it. In other words, it answers it in the negative. 2 does answer the question. If this represents subtraction, then we end up with this, is that equal to that? And
No.
the answer is no, a solid no. So 2 answers it. Now let's see if 1 answers it. By telling us this, they're telling us it's not multiplication.
So it's subtraction or addition.
And neither one of them is this true. So 1 answers it also.
Oh, man.
Only time this is true is if this thing means multiplication. And number 1 says it doesn't mean multiplication. It can't be multiplication, or this would not be a true statement. So number 1 says that it has to be either addition or subtraction. And with either addition or subtraction, that is not equal to that.
Okay. Nice, nice.
Yeah.
All right.
Boy, there's just so many different ways of thinking that you have to use for this. It's not quite as simple as there's 3 techniques.
No.
How many of 60 cars sold last month by a certain dealer had neither power windows nor a stereo?
Now this may be something like a Venn diagram.
This is like a Venn diagram. And
The other one we tried to make it work and it wasn't fitting.
no, I think you're right, though. I think we can use a Venn diagram on these. Let's try it. Let's try to
60
solve it.
cars sold, so that's the total.
So this is power windows. This is a stereo.
Wait a minute, no.
Oh.
The second circle has to be neither.
Yeah, this is neither power windows.
Inside
Oh,
is
no.
total.
Okay. So the rest of it, in other words, a true Venn diagram has a
Only
rectangle around it. And we have this area here.
one. Of the 60 cars sold, 20 had a stereo but not power windows. So I'm going to put 20 in here. So if there's 20, then that necessitates 20 had a stereo but no power window.
So that 20 goes there, right?
No. I'm not, I did it differently, but maybe I'm wrong. Yeah, I think I'm wrong. Let me see, let me set it up. So you did power windows.
We're trying to solve for x. X would be the region where
20.
there's no power windows, no stereo. Let's call Y the region where both power windows and a stereo. So let's assume for the moment that 1 alone does not answer the question. Let's go to 2. 30 had both power windows and a stereo. So this would say that there's no 20 here now, but there's a 30 there.
That seems sufficient, and I'll tell you why. There's an equation, actually. It's not really an equation. It's nothing all that complicated, but it's helpful to remember. It says that in Venn diagrams that to solve for the neither or...
Notice the problem with 2, though. The problem with 2 is that I can put a 15 there and a 15 there. In other words, there were 15 cars sold with power windows only. There were 15 cars sold with stereo only. And there were 30 sold with both. So this gives me, the model I just drew on there gives me an answer of 0, but I could put in any numbers I want for there. And now it's 10. So 2 alone isn't enough information because I could put any numbers I want in this part of the circle.
Okay, so now if we take both of them.
Okay, so now I got 20 there. I got 30 there.
So that means that there's 30, because the stereos, they have only stereos, but the 30 that are inside of there have stereos.
So now I have, right, so this is separate.
There's only 10 with power windows.
Well, either I can put the 10 there, or I could put 5 there and 5 here.
No, there's no outside. There can't be any outside.
Yeah, outside is what they're looking for. Neither power windows nor a stereo. Notice the 2 Venn diagrams I've drawn. You have to have the outside rectangle because otherwise we just have the people that have power windows alone, stereos alone, and both. So you have to have an outside for there to be the neither. So there's 4 categories here. There's stereo alone, there's power windows alone, there's both, and there's neither. And you cannot figure out the neither.
We're in agreement that there's 10 left over, but we don't know if it goes in a power window.
Exactly. We could have it 10 and 0 or 5 and 5, and all of it change this x value. So there's no way to tell. And I actually feel pretty confident about that. I used to really suck at Venn diagrams, and then after working with Eric for a while, I got a little bit better, but it's been a while since we've done any. That's about the first Venn diagram problem we've come against.
And I'm not sure how confident I am with the answer.
I'm very confident on that one. This picture here is a pretty common picture. When you have 4 possibilities, you have the 2 circles, the combined, and the neithers. And the total has to be 60. So if I were to label these with A, B, C, and D, I could say A plus B plus C plus D equals 60. This is probably the standard model of the Venn diagram that you'll want to use for the GMAT questions. At least if there's 4 possibilities. Ah, 127, another GMAT, another Venn diagram. That's nice of them to give us 2 in a row. Again, we have 4 possibilities. We have, they take French, they take Spanish, or they take both. Ah, we don't have the 4th possibility that they take neither. Everybody takes at least 1. So in this case, we don't need the outside rectangle. Since there's only 3 possibilities, we got French, we got Spanish, and we got both. And the total has to be 300. Okay, let's take the first. Now let's take the second one. I like the second one. It's a little easier to put in my Venn diagram. The total of 240 takes Spanish. That means B plus S equals 240. Right?
B plus S. What's the B?
The B is the ones that take both. S is the ones that only take Spanish.
Oh.
So from number 2 alone, I cannot figure out what B is. I know that P or F plus B plus S is equal to 300. Ooh, hold it. I know that F plus B plus S is equal to 300. So F would have to be 60. So now I have 60. Still doesn't help. That still tells me B plus S is equal to 240, but it can be in any combination. So 2 alone does not work. Now let's look at 1 alone. Of the 300 students, 60 do not study Spanish. So that tells me 240 is F. Right? Excuse me. That tells me that 1 alone, 60 do not study Spanish. The only possibility is that 60 is F. Because anybody that's in B or S studies Spanish. So
we have, for certain, we have 100 students that do not study French, so they necessarily study Spanish. And by the same token, that statement 1, 60 do not study Spanish, so they must study French. So
yeah, I forgot about that other information in 1. 100 studies do not study French. 100 students do not study French. Maybe I better go back and rethink the second one here. 240 students study Spanish. 60, that means this is 60. And yet we know 100 of the students at the school do not study French. Well, that doesn't say anything additional.
you know what? I think
It's got to be an X.
I think that 2 may be helpful, because if you have 100 students that do not study French, that means that the remaining 140 study both.
200, the remaining 200.
No, using point 2 with 100 students do not study French. That means those 100 belong in the Spanish-speaking class. So if 240 students study Spanish, 100 plus 140 gives you 240. So those 140 must be in the both.
I don't think so. Let's see. The only thing statement 2 tells us is that 60 study French. Now, because 100 do not study French, that doesn't give us any information. If we know that 60 students study French and some study both, but B plus S has to be 240.
Dave, if they don't study French, they have to study Spanish.
Right, but they could study Spanish or Spanish and French. Oh, no, you're right. Do not study French. So you're right. That tells us that S is 100, huh?
Yeah, S is...
So statement 2 does solve it. Because now we know that 60 plus B plus 100 equals 300. So B has to be 140 that study both.
Well, you're combining both statements there. You're using 60 from statement 1. Yeah, statement 2.
No, not this 60 actually came from statement 2. This 100 came from the stem. So that does allow me to calculate the both. In other words, I'm only considering statement 2 at the moment. Statement 2 tells me that 60 study French. 60 don't study any Spanish, which means they're not in category B, they're not in category S. So they have to be in the F category. And the stem tells me that 100 statements don't study French. So they're not in the F, they're not in the B, they have to be in the S category. So between the stem and statement 2, we get this model. And that model allows us to answer it because we know that 60 plus B plus 100 has to equal 300.
Oh, that was the equation that was missing. If you take if you take just the Spanish speakers, just the French speakers, and just both, then they have to equal 300.
Right.
So yeah, that equals.
Statement 2 and the stem tell us how many people take exactly French and how many people take exactly Spanish. So everybody else has to take both. So 2 works. Let's look at 1 alone. 60 do not study Spanish. That means that's 60.
That means that 240 do.
Well, we still know that 100 do study Spanish, so number 1 gives us exactly the same information that number 2 does.
Yeah. So we're inclined to say both.
Yeah. No, I'm feeling better about these Venn diagram stuff. I didn't used to be able to do these, but now I feel pretty comfortable with them.
So deep.
Yeah. The reason I missed it the first time is because I forgot this statement. I forgot that 100 do not study French, and that's a lot of information. All right. Let's call it a session, Steven.
All right.
And let's see, what do we got next? We're going to do tomorrow afternoon at 4?
Yeah.
From 4 to 6?
Yes, sir.
Okie dokes.
Friday, 4 to 6. And I'm going to see you Saturday.
Right. Saturday morning from 9 to 11.
And I'm going to owe you how much money, Dave?
12 times 28, I think. Through Saturday morning will be $336. We'll have done 6 hours this week, and we did 6 hours last week. Or did we only do 5 hours last week? We did 2, 1, 2, and then another 1. We did 6 hours last week. We'll have done 6 hours both weeks.
Okay.
So
and then,
336 is what you'll owe me after Saturday's session.
But then I have you the following Monday, don't I? For 1 more
Yes,
hour?
you got 1 hour more there. So add 28 to that, you get 264. Incidentally, I have a lot of time off next week. If you need any more sessions, I can certainly put them in there. I think all of these people will cancel. Everybody's on spring break next week. That's why my Wednesday was so maddening, is because everybody had finals. All right, so we got through 127.
Well, I'll give you 364 going in through Monday on Saturday.
Okay. Sounds good. I will talk to you tomorrow at 4.
All right. Thanks, Dave.
All right, Stephen. Bye-bye.